Lean Six Sigma Project Assistance with Artificial Intelligence. What is artificial intelligence? Artificial intelligence is a discipline of computational science dedicated to the development of algorithms, processes, and systems that imitate human cognition, such as learning, reasoning, and self-correction. The roots of artificial intelligence are found in the desire to understand and replicate the processes of human thought and analysis by means of machines. Artificial intelligence encompasses a variety of techniques and technologies, including machine learning, computer vision, natural language processing, and robotics. Artificial intelligence has experienced an exponential growth in capacity and application. Its influence covers various sectors, including health, where it facilitates faster and more accurate diagnoses, the automotive industry, with the development of autonomous vehicles, the financial sector through fraud detection and investment automation, and in the field of continuous improvement and Lean Six Sigma, where it assists in the optimization of processes and improves decision-making. Artificial intelligence has capabilities that are transforming all aspects of society and industry, spreading through various functions and applications. Among these capabilities, the following stand out. Machine learning, artificial intelligence, can analyze large sets of data to detect patterns and trends, learning from them to make predictions or make decisions without direct human intervention. This capacity is essential for the development of systems that improve their performance over time, adapting to new data and situations. Natural language processing, PLN artificial intelligence can understand, interpret, and manipulate human language. This allows machines to read text, listen to speech, interpret the meaning, and even generate text that is coherent and contextually relevant. PLN applications include automatic translation, sentiment analysis, and intelligent virtual assistants. Computerized vision, artificial intelligence has the ability to interpret and understand the visual world. You can analyze images and videos to identify patterns, objects, and classifications. This applies in facial recognition, quality control in manufacturing medical diagnostics through images, and in the development of autonomous vehicles. Intelligent robotics, by integrating artificial intelligence into robots, machines are obtained capable of performing complex tasks, learning from their actions and improving their performance over time. This applies not only to automated manufacturing, but also to space exploration, search and rescue operations, and home assistance and healthcare. Predictive and prescriptive analysis using historical data and artificial intelligence algorithms, future trends and behaviors can be predicted, as well as prescribed actions to achieve specific objectives. In business, this translates into more informed and proactive decision-making, optimization of operations, and customization of offers for customers. Intelligent automation, artificial intelligence can automate complex processes from routine administrative tasks to critical business decisions, improving efficiency and reducing human errors. This frees employees to focus on more strategic and creative tasks. Human-machine interaction. Artificial intelligence improves the interaction between humans and machines, creating more intuitive and adaptive interfaces. This includes the development of advanced recommendation systems, virtual personal assistants, and personalized e-learning platforms. Improved cybersecurity. Artificial intelligence can detect and respond to cybersecurity threats faster and more effectively than traditional methods, continually learning from new cyber attack tactics to protect systems and information. These capabilities demonstrate the vast potential of artificial intelligence to improve efficiency, productivity, and innovation in a wide range of fields, including continuous improvement and the Lean Six Sigma methodology, where it can be used to optimize processes, reduce waste, and improve quality and customer satisfaction. Despite the significant advances in artificial intelligence technology during the 21st century, there are still several limitations and challenges that affect its application and effectiveness. Data dependency, artificial intelligence, especially in machine and deep learning, requires large volumes of data to train the algorithms. The quality, diversity, and quantity of this data are crucial. If the data is biased or insufficient, this can lead to erroneous conclusions or to an artificial intelligence that perpetuates existing prejudices. Contextual understanding. Although artificial intelligence can surpass humans in specific tasks, it often lacks a deep understanding of the context or common sense that humans take for granted. This limitation can lead to errors or misunderstandings, especially in complex or nuanced situations. Costs and accessibility. The implementation of advanced artificial intelligence solutions can be costly and require significant resources, including specialized hardware, software, and experts in the field. This may limit access to artificial intelligence for small and medium-sized companies or for applications in developing countries. Transparency and explainability. Many artificial intelligence models, especially those based on deep learning, are often seen as black boxes due to their complexity and lack of transparency. This poses challenges in terms of explainability, that is, the ability to understand and explain how artificial intelligence reaches certain decisions or predictions. Integration with existing processes. Integrating artificial intelligence into existing business and operational processes can be challenging, especially if current structures are not designed to adapt to automation or advanced analysis. This requires changes in the organization, training, and often a digital transformation. Ethical and privacy aspects. With the increase in the ability of artificial intelligence to process and analyze personal data, significant concerns arise related to privacy, consent, and ethics. Decisions made by artificial intelligence systems can have great impacts on people's lives, highlighting the need for clear regulations and ethical standards. Security and vulnerability. As artificial intelligence becomes more prevalent, so does its attraction as a target for cyber attacks. Artificial intelligence systems can be susceptible to attacks that manipulate their input data or algorithms, which could lead to failures in their operation or to making harmful decisions. Risk of obsolescence. The rapid evolution of artificial intelligence technology means that systems can quickly become obsolete or less efficient compared to new methodologies or algorithms. Organizations must be prepared to update and improve their artificial intelligence systems regularly to maintain their relevance and effectiveness. These limitations underline the importance of addressing the technical, ethical, and social challenges presented by artificial intelligence, ensuring that its development and application are responsible, inclusive, and aligned with ethical principles and human needs. Warnings to take into account. When integrating artificial intelligence into business processes, especially in the context of Lean Six Sigma and continuous improvement, it is crucial to consider several warnings to manage expectations and ensure an effective and ethical implementation. It is not a total solution. Artificial intelligence is not a miraculous solution that will automatically solve all the problems of an organization. Its success depends on the correct definition of the problems, the quality and quantity of data available, and the integration with existing business strategies and processes. Requires human supervision. Despite the autonomy provided by artificial intelligence, human supervision remains essential to ensure that the decisions and actions taken by automated systems are adequate, ethical, and aligned with organizational objectives. Possibility of bias. Artificial intelligence can perpetuate or even amplify the biases present in the training data. It is crucial to carry out rigorous supervision and review of the models to detect and mitigate these biases. Transparency and explainability. Artificial intelligence decision-making processes must be transparent and understandable to users and stakeholders. The lack of explainability can lead to distrust and make it difficult to adopt solutions based on artificial intelligence. Organizational changes. The effective implementation of artificial intelligence may require significant changes in the organizational structure, processes, and culture. Training and skills development are essential to prepare employees to work effectively with artificial intelligence technologies. Ethical and privacy aspects. It is essential to address the ethical and privacy aspects related to the use of artificial intelligence. Organizations must adhere to data protection laws and consider the impact of artificial intelligence applications on individuals and society. Security risks. Artificial intelligence systems can be vulnerable to cyber attacks that disrupt their operation. The security of data and artificial intelligence systems must be a priority. Continuous investment. Artificial intelligence technology evolves rapidly, and maintaining relevance requires continuous investments in updating systems, training, and developing new models. These warnings underline the importance of a balanced and thoughtful approach when integrating artificial intelligence into continuous improvement and Lean Six Sigma strategies. By considering these factors, organizations can maximize the benefits of artificial intelligence while minimizing the risks and challenges associated with its implementation. How should artificial intelligence be used in Lean Six Sigma projects and in continuous improvement initiatives? The integration of artificial intelligence in Lean Six Sigma and in continuous improvement initiatives can significantly transform the effectiveness of these projects. Artificial intelligence, with its advanced analytical capabilities, can complement and enhance continuous improvement methodologies. Below is how artificial intelligence should be used in this context. Identification of problems and opportunities for improvement. Artificial intelligence can analyze large sets of data to identify trends, patterns, and anomalies that may not be evident for human analysis. This allows a faster and more accurate identification of problems and areas in need of improvement. Definition of projects using machine learning algorithms, historical and current data can be analyzed to accurately define the scope and objectives of Lean Six Sigma projects, ensuring that the most critical aspects that affect performance are addressed. Data analysis in the measurement phase. Artificial intelligence can automate the collection and analysis of data in the measurement phase, providing more accurate and detailed measurements, which allows a better understanding of current processes and facilitates the identification of the fundamental causes of problems. Optimization of analysis in the analysis phase. By applying machine learning and data analysis techniques, artificial intelligence can discover complex relationships between variables that may not be evident in a traditional analysis. This helps to identify the true root causes of the problems and generate more effective solutions. Support in the improvement phase. Artificial intelligence can be used to simulate different improvement scenarios and predict the results of the proposed modifications, helping to select the most effective and efficient solutions before their implementation. Monitoring in the control phase. Artificial intelligence can continuously monitor improved processes to detect any deviation or regression from quality standards. This allows for a quick response and adjustments to maintain long-term improvement gains. Training and skills development. Integrating artificial intelligence into Lean Six Sigma requires professionals to be trained in skills related to artificial intelligence. This includes understanding how to interpret the results of artificial intelligence, how to integrate artificial intelligence into the improvement processes, and how to maintain artificial intelligence systems. Ethics and transparency. It is essential to ensure that the integration of artificial intelligence is carried out in an ethical and transparent way, with a focus on improving quality and efficiency without compromising the ethical values or rights of employees and customers. In conclusion, artificial intelligence must be used in Lean Six Sigma projects and in continuous improvement initiatives as a tool that complements and improves human efforts, not that replaces them. Its integration must be strategic, ethical, and value-centered, with a clear focus on improving organizational processes and results. Let's see below a little more detail of how artificial intelligence can assist in the establishment and development of continuous improvement projects. Artificial intelligence can play a crucial role in the initial phase of recognition and proposal of Lean Six Sigma projects, providing a solid basis for identifying opportunities for improvement. Here we detail how it can be effectively applied: data analysis for problem identification. Using machine learning and data mining techniques, artificial intelligence can analyze large volumes of operational and performance data to identify patterns, trends, and anomalies. This allows you to discover problem areas or inefficient processes that could benefit from Lean Six Sigma projects. Project prioritization. Artificial intelligence can help prioritize potential projects based on criteria such as the expected impact, the cost of implementation, and alignment with the strategic objectives of the organization. Using predictive and analytical algorithms, artificial intelligence can estimate the potential benefits of each project and classify them according to its added value. Simulation and modeling. Before the implementation of a project, artificial intelligence can be used to simulate different scenarios and model the possible results of improvement initiatives. This helps to visualize the potential impact of Lean Six Sigma projects and make adjustments before their launch. Detection of variability and defects. By applying computerized vision techniques and predictive analysis, artificial intelligence can detect variations in the production processes or in the quality of the product that may not be evident to humans. This allows an early identification of critical areas that require improvement. Integration of customer feedback. Through the processing of natural language, artificial intelligence can analyze customer feedback and reviews to identify areas of dissatisfaction or demand for improvement. This ensures that Lean Six Sigma projects focus on improving the customer experience and solving problems that directly impact customer satisfaction. Continuous process assessment. With the continuous monitoring of processes through sensors and real-time data, artificial intelligence can constantly identify opportunities for improvement, even after the implementation of projects, ensuring that the process of continuous improvement is truly continuous. Decision-making support. Artificial intelligence provides a data-based analysis that can significantly improve decision-making in the selection of projects. By providing quantitative and qualitative information, leaders can make more informed decisions about which Lean Six Sigma initiatives to adopt. In summary, the application of artificial intelligence in the recognition and proposal phase of Lean Six Sigma projects facilitates a more strategic, data-based, and objective approach for continuous improvement. It allows organizations to efficiently identify and prioritize the projects that offer the greatest return on investment and the greatest impact on quality and efficiency. In the Lean Six Sigma methodology, the define phase is crucial since it establishes the direction and scope of the project. The application of artificial intelligence in this phase can provide an advanced dimension in the identification and definition of problems and objectives. Let's see how. Problem clarification. Artificial intelligence can help analyze historical and real-time data to identify patterns and trends that are not evident. By using machine learning algorithms, organizations can more clearly define problems by discovering the specific areas that need improvement. Definition of SMART objectives. Artificial intelligence can assist in the formulation of specific, measurable, achievable, relevant, and temporal objectives. SMART by analyzing data and establishing realistic and challenging parameters based on historical performance and current trends. Improved process map. Using artificial intelligence, more detailed and accurate representations of existing processes can be created. Algorithms can analyze workflow data to identify bottlenecks, redundancies, or inefficiencies that are not easily visible. Stakeholder analysis. Artificial intelligence, through the analysis of networks and social data, can identify key stakeholders and their influences on processes. This helps to better understand the power dynamics and relationships that could affect the project. Customer voice with natural language processing techniques. Artificial intelligence can analyze large volumes of customer feedback from various sources, such as social networks, surveys, and call centers, to extract valuable information that defines the customer's needs and expectations. Risk identification. Predictive algorithms can anticipate possible risks and obstacles in the implementation of the project, allowing proactive planning and the formulation of mitigation strategies. Benchmarking and comparisons. Artificial intelligence can perform a quick and extensive comparative analysis of how similar processes are performing within the industry or in leading organizations, providing a frame of reference to establish improvement objectives. By integrating artificial intelligence into the defined phase of DMAIC, organizations can ensure a solid start for Lean Six Sigma projects. Artificial intelligence provides a robust database for the definition of problems and objectives, ensuring that projects are well aligned with the needs of the business and the expectations of customers. This leads to more precise and effective improvements, maximizing the return on investment in continuous improvement efforts. In the measure phase of the DMAIC process in Lean Six Sigma, the metrics are established to evaluate the current performance of the process that is being improved. The application of artificial intelligence in this phase can revolutionize the way data is collected, analyzed, and used for evidence-based decision-making. Here are the keys to how artificial intelligence can be effectively applied. Improve data collection. Artificial intelligence can automate data collection from multiple sources and formats, ensuring faster, more accurate, and more complete data collection. This includes structured and unstructured data, which provides a more holistic view of the process under study. Real-time data analysis. Using real-time analysis techniques, artificial intelligence can process large volumes of data as it is generated, providing an instant view of the performance of the process. This makes it possible to identify trends, patterns, and anomalies almost at the moment they occur. Improved measurement accuracy. By applying advanced algorithms, artificial intelligence can reduce error and variability in measurements, ensuring that the data accurately reflects the actual performance of the process. Identification of key performance metrics. Through predictive and prescriptive analysis, artificial intelligence can help identify which metrics are most critical to evaluate and improve the performance of the process, ensuring that improvement efforts are focused on the areas of greatest impacts. Multifaceted data integration. Artificial intelligence can integrate and analyze data from different systems and processes to provide a more comprehensive view of performance, overcoming the limitations of more traditional measurement approaches. Predictive analysis. Artificial intelligence can not only measure current performance, but also predict future trends based on historical and current data. This allows organizations to anticipate possible problems before they become significant obstacles. Reporting automation. The generation of automated and customizable reports through artificial intelligence facilitates the interpretation of data, providing clear and concise reports that highlight key areas of interest to decision makers. Support in database decision-making. By providing data-based analysis and recommendations, artificial intelligence can support real-time decision-making, helping leaders make informed decisions about how to improve processes. By integrating artificial intelligence into the measure phase of the DMAIC, organizations can ensure that the data on which they base their decisions are accurate, relevant, and timely. This establishes a solid basis for analysis and subsequent improvement, significantly increasing the chances of success in Lean Six Sigma projects. In the Lean Six Sigma methodology, the analyze phase focuses on identifying the root cause of the problems encountered during the measure phase. The application of artificial intelligence at this stage can provide significant depth and accuracy in data analysis. Let's see how artificial intelligence can be used. Advanced causal analysis, artificial intelligence, especially through machine learning algorithms, can analyze complex data interactions to identify cause-effect relationships that are not evident using traditional analysis methods. This helps to discover the true root causes of the problems. Data mining and pattern discovery. Artificial intelligence can examine large sets of data to find patterns, trends, and correlations that conventional methods of analysis could overlook. This provides a deeper understanding of the processes and their deficiencies. Simulation and predictive modeling. Using artificial intelligence, organizations can create models that simulate various conditions and scenarios of the process. This helps to understand the potential impact of different variables and predict how changes could improve performance. Process optimization. Artificial intelligence not only identifies problems, but can also propose optimal solutions. Using optimization algorithms, you can suggest the best action paths to improve the efficiency and effectiveness of the process. Customer sentiment and feedback analysis. By applying natural language processing, artificial intelligence can analyze customer feedback to detect feelings and opinions that can provide additional information about the causes of quality or service problems. Integration of data from different sources. Artificial intelligence can combine and analyze data from a variety of sources, including operational, financial, quality, and customer data, to offer a holistic view of the problems and their impacts on the organization. Detection of anomalies and early alerts. Through continuous monitoring and data analysis, artificial intelligence can identify anomalies and alert teams of emerging problems before they become significant failures or negative trends. Hypothesis validation. With the ability to quickly process and analyze large volumes of data, artificial intelligence can test and validate the hypotheses of the root causes more efficiently and accurately than manual methods. By integrating artificial intelligence into the analyze phase, organizations can gain a deeper and more accurate understanding of the underlying causes of the problems. This not only improves the quality of the analysis, but also ensures that the solutions developed in the later phase are well-founded and more effective, leading to sustainable and significant improvements in processes. Artificial intelligence applied to the improvement phase of DMAIC. In the improvement phase of the DMAIC process in Lean Six Sigma, the objective is to implement and validate solutions for the identified problems. Artificial intelligence can play a vital role in this phase, improving the efficiency and effectiveness of solutions. Here we show how artificial intelligence can be applied in the improvement phase. Generation of data-based solutions. Artificial intelligence can use the data analyzed in the previous phases to generate potential solutions or improvements. Using machine learning techniques, you can model different scenarios and predict their results, helping to choose the most promising options. Process optimization. Artificial intelligence can apply optimization algorithms to find the best configuration or process parameters that maximize efficiency and quality. This is especially useful in complex environments where there are multiple variables and interactions to consider. Simulation and modeling. Before physically implementing changes, artificial intelligence can simulate its effects in the virtual environment. This allows organizations to test the feasibility of the proposed solutions and foresee the results without associated risks. Automated experimental design. Artificial intelligence can design and manage experiments to test the proposed solutions, using experiment design (DOE) techniques to efficiently evaluate the effects of multiple variables and their interactions. Support in real-time decision-making. With the ability to analyze data in real time, artificial intelligence can offer continuous support during the implementation of improvements, providing recommendations adjusted to the current situation and allowing quick and data-based adjustments. integration of improvements with existing technologies, artificial intelligence can facilitate the integration of new improvements with existing systems and technologies, ensuring that the improvements are compatible and maximize the use of available resources. Validation of improvement results. After implementation, artificial intelligence can evaluate the real impact of improvements on process performance, comparing the results with the objectives and expectations initially defined. Continuous learning. As the improvements are implemented, artificial intelligence can continue to learn from the new data generated, which allows continuous improvement and additional refinement of the processes. By applying artificial intelligence in the improvement phase, organizations can ensure that the implemented solutions are not only effective, but also optimized for performance. This leads to significant improvements in quality, efficiency, and customer satisfaction, while reducing costs and eliminating inefficiencies. In the control phase of the DMake process in Lean Six Sigma, the objective is to maintain the improvements achieved during the improv phase and ensure that the processes continue to operate at an optimal level. Artificial intelligence can be very useful at this stage to monitor, control, and make continuous adjustments in processes. Below, it is detailed how artificial intelligence can be applied at this stage. Real-time monitoring. Artificial intelligence can be used to continuously monitor processes and detect any deviation or anomaly in real time. This allows a quick response to problems before they become significant failures, thus maintaining the quality and efficiency of the process. Predictive analysis for failure prevention. Artificial intelligence can analyze trends and patterns in the data to predict possible failures or decreases in performance before they occur. This facilitates a proactive intervention to prevent problems and ensure the stability of the process. Automated quality control. Using techniques such as computer vision and machine learning, artificial intelligence can perform automated quality inspections, identifying defects or quality variations, and ensuring that products or services meet the established standards. Continuous process optimization. Artificial intelligence not only helps to maintain improvements, but can also suggest additional adjustments to further optimize processes. This is achieved through the continuous analysis of performance data and the application of optimization algorithms. Change management and adaptability. Artificial intelligence can facilitate the adaptability of processes to changes in the internal or external environment, automatically adjusting the process parameters or suggesting changes to maintain efficiency and effectiveness. Feedback and continuous learning. Artificial intelligence systems can provide constant feedback to project and management teams, facilitating continuous learning and improvement based on the results obtained and the lessons learned. Documentation and automated reporting. Artificial intelligence can automate the generation of reports and documentation on the performance of the process, which facilitates monitoring, auditing, and communication with stakeholders. Integration with business management systems. Artificial intelligence can be integrated with other business systems, such as ERP, CRM, etc., to provide a complete view of organizational performance and facilitate the holistic management of continuous improvement. By applying artificial intelligence in the control phase, organizations can ensure that the improvements achieved are sustainable in the long term and that the processes remain dynamic and capable of adapting to new demands or challenges. This leads to a culture of continuous improvement where stability and process optimization are the norm, supported by advanced technology. Artificial intelligence has a significant ability to transform data analysis and statistics in the context of Six Sigma, especially in pattern identification, trend prediction, and decision-making based on complex data. Artificial intelligence, through its advanced algorithms and machine learning capabilities, can handle large volumes of data with a speed and accuracy that far exceeds human capabilities. This is especially useful in Six Sigma, where data analysis is essential to identify defects, understand processes, and improve quality. Artificial intelligence can run a variety of complex statistical tests and analyses, including multiple regression analysis to identify how various independent variables affect a dependent variable, analysis of variance to determine if there are significant differences between the averages of 3 or more groups, covariance analysis to evaluate the differences between groups while controlling the variability of other variables, chi-square tests to examine the relationship between categorical variables, analysis of main components to reduce the dimensionality of the data, identifying the main variables that explain the variation, factor analysis to investigate underlying structures in data patterns, conglomerate analysis to group objects so that the objects in the same group are more similar to each other than to those of other groups, path analysis to study the direct and indirect relationships between variables in complex causal models, structural equation models to evaluate complex theories that involve causal relationships between variables. Logistic regression models estimate the probability of a binary variable based on one or more independent variables. Survival analysis evaluate the time until an event of interest occurs. Cox proportional risk models analyze and model the rate at which an event occurs. Analysis of time series and forecasts examine sequences of data over time to predict future occurrences. Predictive modeling use historical data to predict future events. Data mining discover patterns and hidden relationships in large data sets. Non-parametric tests analyze data that does not comply with the assumptions of the parametric tests. Statistical process control monitor and control a process to ensure that it operates at maximum performance. Control letters used for the monitoring of processes and the identification of causes of variation. Process capacity analysis evaluate the ability of a process to produce results within specification limits. Multi-objective optimization solve problems that involve several conflicting objectives. Artificial neural networks model complex relationships between inputs and outputs. Recommendation systems predict preferences and provide personalized recommendations. Text analysis and text mining extract useful information from text documents. Detection of anomalies and outliers identify data that deviates significantly from the standard. Supervised and unsupervised machine learning classify data and find patterns without explicit reference. Deep learning analyze data with multi-layered neural networks. Gaussian mixture models used for the modeling of composite normal distributions. Bayesian decision theory apply probabilities and risks to make decisions. Discriminant analysis distinguish between two or more groups of objects. All these methods, just to mention a few, but there are many more that will, of course, depend on the nature of each of the improvement programs of each organization and each Lean Six Sigma project in particular. When making requests for projects or analyses that involve artificial intelligence, especially in the context of Lean Six Sigma and continuous improvement, it is important to follow a series of recommendations to ensure that the results are effective and aligned with the objectives of the business. Here are some guidelines to consider. Clearly define the objectives and expectations. Before initiating any application, it is crucial to have a clear definition of the objectives to be achieved with the help of artificial intelligence. This includes understanding how the implementation of artificial intelligence can improve processes, products, or services. Provide complete and accurate data. The quality and quantity of the available data are fundamental to the success of artificial intelligence projects. Be sure to provide complete, accurate data in the appropriate format to facilitate the analysis and generation of relevant insights. Understand the capabilities and limitations of artificial intelligence. It is important to have realistic expectations about what artificial intelligence can and cannot do. Understanding your capabilities and limitations will help formulate applications that are viable and practical. Consider integration with existing systems. Evaluate how the artificial intelligence solution will be integrated with existing systems and processes. It is essential that the request contemplates compatibility and integration to avoid implementation problems. Establish clear success criteria. Define what will constitute a successful result for the artificial intelligence project or analysis. Establishing clear and measurable success criteria from the beginning will help evaluate the effectiveness of the artificial intelligence solution. Prioritize data security and privacy. Make sure that any artificial intelligence request complies with data security and privacy regulations. The protection of sensitive and personal data should be a priority in any artificial intelligence project. Encourage collaboration between teams. Effective collaboration between artificial intelligence, IT operations, and business teams is essential for the success of projects. Facilitating communication and collaboration from the beginning of the project can significantly improve the results. Preparing for change and training. The implementation of artificial intelligence solutions may require changes in processes and employee training. Be sure to include in the application considerations for change management and the necessary training. By following these recommendations, organizations can significantly improve the chances of success of their artificial intelligence projects, ensuring that the solutions implemented are effective, safe, and aligned with the strategic goals and objectives of the company. To make requests through chats, looking to make them more effective and generate more accurate and useful answers, you can follow the following structure and tips. Define the goal clearly. Clearly indicate the topic or question you need to solve. For example, if you need information about the application of artificial intelligence in Six Sigma, specify which phase of the DMake you are interested in focusing on. Context. Provide a little context about why you need this information. This will help adjust the response to your specific needs. Detail the important requirements and details. Include specific details you need in the answer. For example, if you are looking for examples, case studies, definitions, or statistical analysis. Limitations. If there are limitations such as the number of words, level of detail, or specific approach, mention them. Response format. Indicate if you prefer an explanation, a list, a detailed analysis, a step-by-step guide, etc. Data presentation. If you need graphics, tables, or any other visual format, specify this requirement. Prioritization and importance of topics. If you are asking for information on several topics, prioritize or indicate if some are more urgent or important than others. Clarity and accuracy. Avoid ambiguities. Be as clear and direct as possible in your request to avoid misunderstandings. Use of examples. Providing examples can help clarify the request. Open to follow-up indicates that you are open to a dialogue or follow-up to clarify or deepen the information provided. Let's look at an example of how to make a good request to an artificial intelligence engine. Include the topic to be addressed. For example, application of artificial intelligence in the measurement phase of the DMake in Six Sigma. Include the objective, for example, I need to understand how artificial intelligence can optimize the measure phase in a Six Sigma project, specifically for the improvement of manufacturing processes. Include the important details. For example, I want examples of artificial intelligence tools applied and the type of data they analyze. Include the response format. For example, I prefer a list of tools followed by a brief analysis of their functions. Include priority. For example, this topic is of high importance for my current research on improvements in manufacturing. Include the clarity of the answer. For example, please include specific examples of the manufacturing sector. Include tracking. For example, I am open to a dialogue to to delve into any tool or method mentioned. Following this structure and advice, your requests will be clearer and the artificial intelligence engines will be able to provide you with answers more aligned with your needs. We have prepared a guide document for the use of artificial intelligence engines in their most basic interaction through chats. This guide contains assistance for all the DMA phases and the 28 steps according to the ISO 13053 standard that ranges from general support requests to detailed topics such as the application of a specific tool to obtain the solved method as well as interpretation and recommendations. If you want to use this guide, you only have to copy each application text and paste it into the artificial intelligence engine. In the event that the example requires data, these have been included as links to files that you can also access. Let's take as an example a basic request to an artificial intelligence engine where we want to have an understanding of the process through graphical analysis. In this case, the exercise is prepared in ChatGPT version 4 and is part of the examples in this guide that you can consult in the additional resources. Suppose we are analyzing the transport of raw materials and we have collected a lot of data for more than 30 variables. Our focus is to be able to reduce fuel consumption and improve the variability of each trip. So we are going to write the following to the artificial intelligence engine. As an objective, to visually understand the data we have collected, we will also give you the context of our request. In this example, we explain that we are running a Lean Six Sigma project and we have collected information about the process. We also give you information about the content of the variables collected. As a specific question, we ask you for a summary of the analysis for the variable of interest and the rest of the variables collected. Since there are some restrictions, we include in the request that there is missing data and that you must use all possible data. Likewise, we emphasize that for the moment, we only want a graphical analysis. And finally, in the expected result, we ask you to give us a list of the most important explanatory variables, but to provide us with a graph of them. In addition, we are going to upload the file with the collected data so that you can use them for the assigned task. Keep in mind that some engines may allow you to load the data, or they will allow you to include the direct access link to the cloud where it can access them. Once our entire request and the related data have been detailed, we send you our request as if we were chatting with someone else. Let's see the result of this request. At the time of executing our request, the artificial intelligence engine will process the data and our request, and will give us the explanation of what has been done as well as the requested graphs. The first description reads like this. The file contains data that includes a response variable, kpl kilometers per liter, and several explanatory variables, which possibly influence fuel consumption. Some of these variables are dates, times, travel IDs, percentages of conditions, differences in liters, driving hours, among others. To visually analyze the relationship between the response variable and the explanatory variables, I will make graphs that show the correlations and relative importance of these explanatory variables. This will allow us to identify which of them have the greatest impact on fuel consumption. We will proceed with the visualization, taking into account the presence of missing data. Then he decides to show a heat map in order to visually show the variables that have the greatest relationship with the response variable. In this example, the intense blue represents a strong positive correlation, and the intense red color represents a strong negative correlation. He also adds that in this analysis, the variables that show a greater positive or negative correlation with the KPL can be considered as the most important in terms of influence on fuel consumption. These results help us identify which explanatory variables deserve more detailed attention in subsequent analyses to better understand their impact on fuel efficiency. Then, interactively, we ask the artificial intelligence engine to add dispersion graphs for the first 4 variables, to which in an interesting way it decides on its own to show the four variables that have the highest positive and negative correlation. In a complementary way, it tells us that it provides us with the dispersion graphs for the first four variables with the highest absolute correlation with the response variable kilometers per liter kpl. These graphs show the relationship between fuel consumption and each of these explanatory variables. Dispersion can help visualize patterns, trends, or groupings in the data and provides an initial perspective on how these variables can influence fuel efficiency. We invite you to explore the guide to the use of artificial intelligence and try to process some examples to some artificial intelligence engine in order to evaluate the answers given. Remember that this tool must be used with care and supervision.